Now, our next contestant, may I please invite Miss Tanyawan and her talk on an alternative of antibiotics. All right. Hello, teacher.
Hello.
Hello. Hi. Are you ready to teach us?
Oh, yeah?
Yes, of course. Then please, you may start.
Thank you very much. Every year, bacterial diseases become more drug resistant. The ones that cannot be killed by antibiotics survive, replicate themselves, and pose a threat to the future humanity. Scientists are calling this as like the superbugs. The key to fight with all the microbes is to understand how they work. Bacteria are single-cell organisms. You know what? When they're alone, they act like independently. But when they attack the host, they do so as a team. In this regard, they exhibit social behavior. When the bacteria grow enough, it will start secreting the small molecules surrounding them. This is called the quorum sensing. Quorum sensing molecules are created by the bacteria. And the quorum sensing is used to detect the surrounding population density of the bacteria. Once they detect that they got enough population, they will help each other to produce a structure which is called the biofilm. This is going to be the protective shell that keep them safe and make them become stronger. But if the biofilm is not created, the bacteria will lay dormant. A scientist team from the United States brought this really cool idea to develop the alternative to antibiotics by creating the small molecules, which is to anti the working of the quorum sensing, which is called anti-quorum sensing molecule. This is the picture of the single bacteria. Normally, bacteria has the receptor on their surface to receive the quorum sensing molecule. The scientists put this small molecule into the reaction, and then it binds at the receptor, and then it shuts down the communication of the bacteria. And this bacteria cannot talk, cannot hear, cannot detect the surrounding population, and they cannot expose the social behavior. Then the biofilm will not be created. That colony of the bacteria will become less tolerant, and they will die from their limiting factor. Anti-quorum sensing is unlike traditional antibiotics, which kills bacteria directly. Weaker bacteria will die, while the drug-resistant bacteria survive and keep replicating. And that leads to the rapid mutation. Oh yeah, I'm talking about the evolution of the superbugs. In conclusion, anti-quorum sensing is providing more sustainable solution to prevent humans from bacterial diseases. Thank you for listening. ขอบคุณค่ะ
Thank you very much.
Thank
Kun
you.
Tanyawan. That's a very interesting talk to me. A new word for me, quorum sensing.
Thank
Is this
you
a new
so
word to
much.
anyone else? Can I ask? Right. At least you under. Right. Okay then, the judges, are you ready?
If you can block that receptor, you know, like sending something to really attach to the receptor and block it, will that work to anything, right?
Before we answer that question, we should know the background of the kind of like the working of the receptor, because of the receptor of on the cell membrane. Normally, it's kind of like made from protein. So the working of protein, they use the lock and key theory. Okay, so it's kind of like, if you can see from this picture, so from the receptor, we call the active site, it should be specific for this molecule too. If it's not the same shape, it's not gonna be, it's not gonna compatible. So if it has the similar shape or it has the similar chemical reaction, so it will work in that case.
So it will work for any particular kind of bacteria only?
It's kind of like, it has to be pretty specific. It's just like human. If I explain by using a lot of scientific, it will be too complicated. But it's just like human. We have so many types of human. Like we have Asian people, we have foreigners, Western people. We are human, but we just kind of like we have different types. We speak different languages, right? So the the quorum sensing, it's kind of like specific too. Each bacteria, they have the specific type of the quorum sensing molecule as well.
So if the same bacteria, but after the mutation, is that possible to use the same process in order to eliminate it?
Because of this innovation is kind of new, so it's there's no one to conclude that it's better or it's kind of like worse. But it's kind of like it used because of when we kill something, we have natural selection or evolution. So when we kill something directly, they will evolve. That's why we have to keep changing the formula of the pesticide. So it will be kind of like more dangerous for human and other organisms. But if we kind of like shut down some system, it's kind of like we kill them by using the life cycle. It will be more sustainable because we don't need to keep changing the formula of antibiotic to be like more dangerous and more intense. So it kind of like it's better in that way. It's more healthy to organisms.
Besides using the anti-quorum sensing blockers, so that means you still need to use the antibiotics in order to kill those bacteria, right?
Yes.
Well, thank you. And again, I like your talk again.
Thank you.
It's a very, very, I would say, very easy way to explain the quorum sensing in 3 minutes, and I understand completely. Thank you.
Over 3 minutes, but...
A little bit.
All right then. Thank you very much to judges, and of course, thank you very much, Kun Tanyawan.
ขอบคุณค่ะ Thank you very much.